If I'm being honest, I really did not expect any less from Michelle, so thank you for that, Michelle. Next up, we have a well-seasoned engineer, and if you're not familiar, you better get familiar. Marc is Tech's vision of the NFL's legend Tom Brady. He is nowhere near ready to hang it up and stop collecting those rings. He started off in the gaming industry and peaked enough that his name is in the credits on at least 10 video games, including the Battlefield and MotorStorm for PlayStation 3. A double boomerang, joined CircleCI in 2014 before moving on to Flipdish in 2016, doubled back to CircleCI in 2017, just to come back to Flipdish, where he's been dominating the role of principal engineer, helping the engineers solve hard problems. So please give a huge applause to Marc O'Morain, who's our version of Tom Brady from the NFL. Thanks, guys.
Thank you. Get my clicker up. Okay, so that's me, Marc O'Morain, principal engineer at Flipdish. This is my 5th year at ShipItCon, first time speaking. But remember back last year, hands up, who was here last year? One of the talks early on in the day, someone mentioned finish your migrations. And I noticed every speaker after that mentioned the same, finish your migrations. So my one piece of advice for everyone today is finish your migrations. Quick intro about Flipdish, what we do to set the stage, what I'm going to talk about. We make software products and hardware products for restaurants. So starting from the side here, we have apps for consumers so that they can order food online through an app, order through a website. We make websites for our customers. We have a CMS, they can build their own websites. And then in the store, we have kiosks that let people order food. At the front of the house, then, we've got the point-of-sale system. And then in the kitchen, we have printers, we have kitchen display screens. We've got software and hardware throughout the whole of the restaurant's business. And our focus is really on quick service restaurants, so takeaway, delivery. We launched in 2016, and since then, we've processed 50 million orders. And we do about 1 million orders a month at the moment. So that's kind of a sense of the scale of what we're doing. And I'll talk a bit about what the back end does. The talk today is going to be back end focused. So this is what we do. We get orders in. So an order might come from an Android app, an iOS app, from web, but also from a partner. So we've got Google, Just Eat, Uber. Orders like that will come in, and also in-person orders from the point of sale, and over the telephone as well. We'll get orders in. And then we send the orders out. So we have 5,000 devices live in kitchens. So an order, we might send it to your point of sale, depending on how you want to take the orders in. It might go straight to the screen in the kitchen. It might go to a printer where we print it. It might go to a little screen. So we're routing the orders around. And then we also send orders outwards to partners. So you might order through Flipdish, but your food might be delivered through an Uber Direct driver that's working with the restaurant. So we route orders into Flipdish and then out to these partners. And also, you might have a third-party point of sale, so a Lightspeed or a Clover point of sale. The order comes into Flipdish, and we'll put it to your point of sale, not ours. So that's the kind of flow of what we have. So the characters today, we've got a tale of 2 monoliths. Our first monolith is Zeus, and our second monolith is the RMS, our restaurant management service, but this is our point of sale system. So Zeus. A lot of people in this room have probably worked on Zeus over the years. It's a C# ASP.NET app. It was started in 2014, and it was written with a very modern tech stack for 2014, and that's where it's calcified. It runs as an Azure app service. It's got a SQL database, Redis, table storage, and it runs with the Azure Service Bus as the central queue. Quite a standard stack, but it's stuck in that 2014 technology. In preparing for the talk, I was asking around on Slack to get a flavor from our engineers about what Zeus does to explain to you. And as Adam pointed out, it's easier to explain what Zeus isn't. It's a URL shortener. It's a website builder. I think it can terminate TLS for thousands of restaurants. It can register domains. My favorite feature, it can build and deploy an iOS app. So within Zeus, you can press a button and a CircleCI build will run, build an app, submit it to the App Store, all controlled by the monolith. It does everything. The RMS then, so we acquired a company in 2022, which gave us the point of sale capability. It's a very similar tech stack to Zeus in terms of its shape, which is actually something we liked when we were talking to the company about acquiring them. It's written in Node.js rather than C#, but apart from that, it's the same shape. It's a web app, it's got a SQL database, table storage, service bus for its central queue, but crucially, it is a modern, well-structured code base. So, the most important question any engineer can ask, what problem are you trying to solve? This is the problem. This is 2022. We had to ship RAM out and special star-shaped screwdrivers to all of our engineers because Zeus wouldn't build anymore on our laptops. They'd just gotten too big. So the Zeus code, the stack, the tests, and the deployment all slow down delivery. And we're going to jump into each one of those areas. So the code. Writing code in Zeus is slow. Opening the editor, opened it yesterday to take these screenshots. It took 4 or 5 minutes for the IntelliSense to catch up, for the editor to load up. You're just sitting there. Tasks that should be instant take minutes. You know, you right-click on a test and say, run this one test. It takes a minute to build and run. It's just slow. So we get this kind of relationship where as we add files to Zeus, it gets bigger and bigger, and the time to open the editor takes longer. When I go back, we got this linear relationship, which is important. So the stack then, we're tied to this obsolete technology stack. We're stuck on .NET Framework, we're stuck on IIS, on Windows, on ASP.NET. Entity Framework holds us back. We've numerous times over the years, we've tried to upgrade to the newer .NETs, but those projects have never yielded fruit. And we spend time working around problems that other teams don't have. So this screenshot here, on Wednesday, we had a minor incident, thread exhaustion problem. And I know exactly what it is. It's a particular point in the request pipeline in ASP.NET. We can't run async await code. We have to have a synchronous call to the database and Redis. If you're using modern .NET, that's not a problem. If you're using Node.js, it's not a problem, but we have the problem. So our engineers are solving these problems that other people don't have. Tests. Writing tests is slow. Testing Zeus is slow. We have low unit test coverage because the code is hard to test. So therefore, we write integration tests. They're slower to run. They're flaky. We have too many integration tests. So the time to run the test suite just grows and grows and grows as we add tests. And because they're more predominantly integration tests, the chance of anyone being flaky increases over time. So again, this linear relationship is slowing us down. Deploying is slow. It takes about an hour to run the pipeline, run the tests, get a build out. We limit our deployment window from 10 a.m. to 4 p.m. We don't want to deploy during dinner time, which gives us kind of max 5 deploys a day. But the reality here is if you're writing code anytime after lunch, it's not getting out that day. It's going to be the next day before you get a chance to deploy. So you're just adding days worth of latency to every change. And these all compound. So if it's slow to write code and then it's slow to release, refactors are slow, which means it maintains being slow to write code. And they keep feeding into each other, and slowing us down. So which gives us this relationship. The time to ship a change just goes up exponentially as we add features because we have all those linear graphs compounding on each other. So what problem are you trying to solve? This is the most important question an engineer can ask. We have 2 systems. We've got the online ordering system, Zeus, and we've got our point of sale, the RMS. And you can see there's an overlap here. But when we zoom in on that overlap, there's a lot in there. We thought point of sale and online ordering are very different domains, but once we kind of started trying to merge the products together, we realized there's user accounts in both, there's audit logging in both, there's vouchers, opening hours, big overlap. And this led to problems for our clients and our customers. So our clients are the restaurants themselves. They need to log into 2 different portals. They've got 2 logins, 2 passwords. We've got settings that you need to keep in sync. Your opening hours on the point of sale, your opening hours for online ordering are separate. The customers in store would see 2 different experiences, which we'll go into later. But now we're going to jump back in time and talk about our ecosystems team. So in 2021, we started a new team, fully remote, time of big growth for Flipdish. Excuse me. So during COVID, every restaurant started doing delivery. Huge growth. Big employment change at Flipdish, employed a ton more people. We went through a bunch of changes of leadership as we scaled up, and then we had to, I think 2023, we did a round of layoffs, and we scaled down again. Big changes over the years, but at every one of those changes, we kept the ecosystems team together. The mantra was keep them delivering, because that team is delivering. They had high morale, they were collaborating. So let's dig into why they were delivering. The ecosystems team were managing integrations. So some integrations inside Zeus and some integrations outside our monolith. And an integration for us is dealing with a partner like Uber Eats, Deliveroo, Glovo in Spain, Google Maps. And they had this sort of architecture where the online ordering system is sending out webhooks. Those webhooks are being caught by an Azure function. And that function then is transforming the data. So for example, you change your opening hours in our portal. It's picked up by a Lambda, and we can update that on Google Maps then. So the Google Maps keeps your opening hours up to date. So they had this integration engine. So every integration was a separate Azure function, separate deployment pipeline, separate unit tests, no release windows. That seemed to be their superpower. And they were upgrading things. So over the years, they went from .NET 5 on Windows to Linux. They went to .NET 6. They went to .NET 8. They hit a bunch of problems with Azure Functions, wouldn't recommend it. They moved back to running on Azure's container service, and they were able to make that change because they could do it incrementally, one by one integration, then the next, then the next. It wasn't a big monolith. They could make small incremental changes. So today, they've got 7 integrations running, 3 shared services, 1 million requests a month running through the system. Their SLIs are great, reliability is great. So fast forward now, 2024, Loyalty 360. So what problem are you trying to solve? This is the most important question any engineer can ask. We have 2 separate loyalty systems, one in the online ordering system and one in the point of sale. This is a problem for our customers. So you might have a loyalty campaign where you get stamps on your card every time you order. Your 5th order is free. You order 3 times online. That goes into one monolith. You order twice on the phone. That goes into the point of sale. Separate loyalty card. You get 2 stamps there, and you get no free meal, which leads to confused and unhappy customers, which leads to confused and unhappy clients. So this is the problem we had to solve. This, though, was a burn the ships moment at Flipdish. We decided we're not going to try and fix Zeus. We've had many projects over the years where we're trying to upgrade it, trying to fix it up. No, we're not going to do that. And we're also going to protect the RMS. We like its code base. We're not going to jam features into the RMS and let it become this massive monolith the way Zeus has. So we're going to build a new stack, a new system, and we're going to choose the technologies that a competitor, if a new competitor started in 2024, what were they choosing? That's what we were going to choose. And we're going to solve these Zeus problems and empower our teams with confidence and autonomy so they can ship in that way the ecosystems team we're shipping. We're going to go all in on serverless. So the project, as I mentioned, was called Loyalty 360. It was a greenfield implementation of loyalty. So we weren't carving up the monolith. We're not pulling code out of Zeus or out of RMS. It's a greenfield implementation. It lets us remove the code from Zeus, remove the code from the RMS. Very small team. We had 3 developers, a PM, and a product designer, and a very short timeline. We had 1 commercially sensitive customer that we agreed we'd ship this for within 2 months. So we had a very clear goal of shipping a solution for this loyalty problem for this 1 client. We had support from the CTO who was driving the project, and we had an SRE and an infrastructure engineer in a support role with us to help us with anything we needed. So how can we build outside the monolith? The ecosystem team had shown us the way. We had a serverless first stack, everything running on AWS Lambda, event-driven architecture with Event Bridge, storage was all in DynamoDB, infrastructure as code using AWS's CDK. So that's a TypeScript way of defining your stack, a lot like Terraform. No ClickOps allowed. And we chose SST, which was based on friends of ours in the industry that we were reaching out to get stories of their serverless experience recommended this tool. SST is a sort of layer above AWS Lambda and CDK, but crucially, it's not a framework. It's not abstracting anything away. It gives us full access to the Lambdas, to the CDK code, but it gives us live reloading. It has a great deployment story, a great CDK story. So a great tool that just has a lot of shortcuts and a lot of nice properties on top of Lambda without hiding Lambda from you. With two problems with building outside Zeus. The authorization system was stuck inside Zeus, and the domain events were stuck inside Zeus and the RMS. So we want to stamp a loyalty card when your order is created or when a sale is made on the RMS, but we had no access to those. So for the authorization problem, we added a new HTTP endpoint to Zeus, which would let us take our JWT token or our cookie or whatever auth you have, send it to this one endpoint, which would return back details of who you were logged in as, what grants you had, what permissions you have. A lot of gunky code in that. We had to deal with all sorts of permissions. You can imagine we've got these 5,000 devices in the wild. They have all sorts of auth systems built over the years. We needed to support them all. So we built this endpoint on Zeus, wrapped it up in a Lambda, so we don't need to look at the code, but it's hidden away from us. So we were able to isolate our new systems from the gunk, but crucially, we weren't building a new authorization system. We just added something to Zeus to unblock us. And then for domain events, we came up with this amazing serverless solution where the events on service bus could be sent to an Azure function, which could trigger a HTTP call. That could go over to AWS, trigger a Lambda, which could put something into EventBridge. And we really quickly scrapped that plan. We were not building an event repeater system. We were trying to solve Loyalty 360 for one client in 2 months. So we wrote a C# function in Zeus to put a message on EventBridge as it was putting it on the service bus. 10 lines of code. It works. What problem are you trying to solve? We're not building event repeater systems. We're not building a new authorization layer. We're solving this loyalty problem. This is what we came up with. So the online ordering system and the point of sale are in Azure. They publish events out to EventBridge. And then we have our new system running on AWS Lambda, Loyalty 360, consuming these events. And it knows nothing of Zeus. It knows nothing of the point of sale. It's greenfield, just listening to events on EventBridge. So we've isolated ourselves there from the old stack. The results. Code. Writing code in Zeus is slow, as we've seen. SST gives us hot reloading of code. Hot reloading of code is different than it being fast. Like I said with Zeus, it might take a minute to run a test. With the SST setup, it's not 30 seconds, it's not 10 seconds, it's hot reloading, it's instant. You save the file, it's live reloaded. So it's not a speed up, it's like a sea change of how fast we get. Hot reloading of infrastructure. This blew my mind when I saw it the first time. With your CDK code, if you want to add a new Lambda or add a new DynamoDB table, you can edit your stack file that contains it and save it, and SST just starts deploying it. So in the past, like in Zeus, if I wanted to add a new Redis database, I'd make a Jira ticket, assign it to the infrastructure team. The following week, they might pick it up, get me my Redis database, get me credentials, weeks and weeks. With the SST setup, I can just write a new Redis in the CDK file, save it, and a couple of seconds later, it's there. Testing. It's all greenfield code, so with Zeus, it's slow. We're starting from scratch, so we can have the tests run in watch mode. Again, they're just running instantly. As you write code, as you save the files, the tests are run instantly. SST also allows us write tests for the infrastructure. So our CDK code is our stack described in code. We can write tests against it, which is a capability we never had with Zeus. Deployments, they take 3 minutes. You can ship whenever you're comfortable. We have no deployment windows. With the monolith with Zeus, there's always a risk that if you change something over here, you break something over there. So we have to be very conservative with how we release. With the new system, if you break loyalty, that's all you've broken. You're isolated from them, so we can take more risk. We can deploy faster. Teams don't block each other. If one team writes a new service and has a flaky test, it doesn't block another team because they have their own pipelines. Compounding. So the problems in Zeus all negatively impact each other. The benefits of the new stack all positively impact each other. So before we had this graph, this exponential growth in the time to ship a change. Now we have this shape. So we can't get away from that exponential growth. As we add any more and more features to any one service, the time will grow to deploy it, but we are artificially capping that growth by separating out systems into different services. so each service stays fast. So what's worked well for us? One repo. The whole service is in one repo. The CDK code, the source code for the service itself, the pipelines are in GitHub Actions in the one repo. The secrets are managed using GitHub Secrets that we push out to AWS. Teams have admin access to their own repo. They can set their own code review policies. They can accept shared source pull requests, set themselves as code owners. They're in full control of their repo. They don't need to reach out to any other team to ship. AWS accounts. Each team, we've given them their own AWS account, and that acts like a bulkhead between teams. So we get isolated observability, isolated costs. So each team having their own account, each team has their own costs. We can track them really easily. All the AWS metrics are sent into Datadog. With that, we've got the account per team, so everything's automatically tagged and compartmentalized. And you can't break any other team's AWS account. You don't have access. So we can give you full admin access to your account. You can break your stuff, but you can't break any other team's stuff. You're separate. What hasn't worked well? Serverless has been a net positive, but we have hit problems. Data migrations. We don't have a good way of doing these still. If we write new features in our new stack, that's great. We have no data to import, so we can just get going. Taking out these shared services like loyalty, we need to import your previous stamps into the new system. We've tried a bunch of different ways. We have Parquet files, S3 exports. We still haven't found a nice way to do this. Love to talk later on at the party about data migrations with people, one of my favorite topics. And uncertainty is the other one. So we've tasked our engineers with upskilling on new technologies. So we hit issues with the number of resources you can have in an AWS stack. DynamoDB is lower level. It's fundamentally different to SQL. Things you could do in SQL you can't do in Dynamo. The last point here is the rules around the event bus and what events are getting sent around with EventBridge. It's difficult to debug and see what's happening, and our teams have been great at dealing with it, but we've asked a lot of the teams to come up and learn this whole new stack. So here's where we've shipped Loyalty 360. You can see at the start, this is where we shipped it for new clients, which meant we've solved the problem. That split brain problem between the two systems. All new clients are being brought on the new systems. We'd solved the problem. And then later on, I think that was June last year, and then March this year, we shipped, it turned it on for everyone. So we had to deal with some migrations and some other weird stuff before we could flip over. So that's when the full value was unlocked. So finish your migrations. That's the most important point. You can see here we solved the problem at that first point, but we didn't get to delete the code until the second point when we'd migrated everyone. So we didn't get to really, the clients got the value at the first point here, but internally we only got that value at that second point. So finish your migrations. So fast forward 2025, what happened next? Micro front ends. So what problem are you trying to solve? This is the most important question an engineer can ask. A third monolith appeared. So we had a monolithic UI, a single page web app built with React and Vite. It's our web portal. So it's a single portal where our clients can log in to run all the back office for their restaurant. Every Flipdish feature exposed in one massive single page app. Flaky tests with WebDriver IO blocking teams. Slow to upgrade. The JavaScript ecosystem loved to change APIs every month or two. Like React Query, for example, we had to upgrade. It was a breaking change. The whole app needed to be upgraded all at once. So all these Zeus problems also appearing in the front end. So we came up with a micro front end system. So this is a typical page. You see we've got the left nav down the side and then the main content. And we broke it up like this. Teams are able to give themselves a new route up the top and insert something in the left nav. And then everything in that blue square there, that's a micro front end, which lives in that same repo. So our new SST apps, they have the back end, they have the infrastructure, and now the front end is in that repo too. And we get live reloading of the front end and live reloading of the back end. So the big change here, project I'm working on at the moment, when I start it up, I can CD into the repo, I can start the front end, start the back end Without running Zeus, without running the web portal, I can have my front-end library loading, I have my back-end library loading, and I have my editor with cursor, where I can just go so much faster than I've ever been able to. You can just make a change, save it, the front end updates, the back end updates, schema changes. We'd have issues in the past where one engineer might be tasked with updating the back end in Zeus for something. They'd make an API, build an API client, a front ender would then pick it up, and in Portal they'd implement the front end changes. It's all in one repo now, so you can have one TypeScript definition file for your data contract, write your back end, write your front end, ship it. Teams can also all deploy independently. So like I said, with Web Portal, it was one code base, so any one team breaking the build broke it for everyone. So fast forward to today, got 90 seconds on the clock. All new features, we're all writing them on the new stack. So we've got two kind of overarching work streams. New features written on the new stack, and we're also having to go back and find these duplicate systems and pull them out and put them on the new stack as well. But crucially, are we shipping value? So this here is an SMS campaign tool that we wrote. So the idea is our clients can go into the portal and start a new SMS campaign to maybe retarget people that hadn't ordered, maybe Champions League night tonight, why don't you order a pizza, these sort of messages. This system was written in the new stack. It's front end, it's back end, everything outside of the monolith. You can see here we shipped, we ran a marketing email to our clients. So that dark launch period in purple at the start, ran the marketing email. We've got clients using it. So we are shipping value on the new stack. And then this, I pulled out a Datadog this week, which I really liked. This is the last 2 years, the number, the graphs, not quite, but roughly the number of deploys per week. And we've 10x that from June last year to August this year. Massive improvement in the number of deployments we're running, which I was really happy to pull this out. I went into Datadog seeing, can I get any positive results out of this? And I was like, yes. Okay, thank you. Minus 5 seconds. I mentioned Brenny over here. We're hiring in Dublin for 2 tech leads. We're looking for a React Native tech lead and one for the client experience team with me, working with me. Talk to Brenny over here, please.
Thanks for that, Mark, and make sure for anyone who is looking for a new role to talk to Brenny. I hope that we've whetted your appetites this morning, but alas, we'll venture for a small break. So don't forget to enter the raffle because there are a load of prizes up for grabs, as well as popping over to Vicky over here to build your badge. There's a prize for that as well. We will reconvene in 15 minutes. Guys, get acquainted, get your coffee, and I'll see you in 15.
We're gonna dance all night to this DJ. Sugar dance all night to this DJ.